Welcome to problem 26. Our problem is that a trough is 12 feet long and 3 feet across the top. Its ends are isosceles triangles with altitudes of 3 feet. Part A of the problem is, if water is being pumped into the trough at 2 cubic feet per minute, how fast is the water level rising when H is 1 foot deep? Part B. If the water is rising at a rate of 3/8 inches per minute when H is equal to 2, determine the rate at which water is being pumped into the trough.
Okay, so here we've got our trough. Our known variables are that our volume is equal to base times length, which could also be 1/2 base times height times length, because we've got the base of a triangle times the length of the trough. The dimensions of the trough are that the length is 12 feet, the height of the triangle is 3 feet, and the width of the triangle, or the width of the trough, or the base of the triangle, is also 3 feet. And we know that the height of the water is changing at 2 cubic feet per minute when the height starts at 1 feet deep.
For part A, we need to find the change in height of the water, which is dH over dt. So for our equation, 1/2 base times height times length, we don't know the change in the base, so we have to get rid of it. And to do that, we need to set a proportion. Okay, so we have V over H equal to the current values, which are 3 over 3. Cross multiply. And get H equal to V. So now we can substitute that information into the equation. So instead of V equals 1/2 base times height times length, we have V equals 1/2 H squared times length. And now we can put in 12 as the length because it's a constant. So now our equation will be squared. Now we can take the derivative of this and get dV over dt equals 12h dH over dt. Now we just plug in our values. 2 equals 12 times 1 dH over dt. Solve for dH over dt. Equals 1/6 feet per minute. That's your answer. So for part B, we are given that the water is rising at a rate of 3/8 inches per minute, which is dH over dt. So in this case, we can still use the same equation, V equals 1/2 V times H times length, which you can again change it to V equals 1/2 H squared times length, and again plug in 12 as a constant for length. So you get V equals 6H squared. And we'll take the derivative, so it's dV over dt equals 12h dH over dt. Now we're solving for dV over dt, so we plug in the other values. 12 times 2 times 3/8. And we get dV over dt equals 9 inches, which can be converted into feet, so dV over dt equals 3/4 feet cubed.